Hi, I'm Carol, and this is the Hyperquilt. I built it to help me understand hyperbolic geometry. The gag is quite simple. Any quilter knows that 6 equilateral triangles will fit together and make a nice flat hexagon, and quilters like things to be nice and flat. I put together 7 equilateral triangles and got a quilt that is not flat. It's only an approximation of a hyperbolic plane. Locally, each one of these triangles is still a Euclidean triangle, but when I sew 7 of them together, you can see that it bubbles up. Now, I'm going to explore some features of this. What happens in hyperbolic geometry? Well, parallel lines diverge. That's counterintuitive. You can have a point, you can have a line, a point not on the line, and more than one line through that point, which is parallel to the original line. Also not intuitive. And it might make your mind explode is that triangles do not add up to 180 degrees. And there can be no rectangles. Okay, let's see if I can explore this on this quilt a little bit. We have to decide what we mean by line and what we mean by parallel. So line is going to mean geodesic. It's going to mean the shortest distance between 2 points. And how do I find that on the Hyperquilt? I find it like this. I just stretch it. So if I stretch from here to here, okay, I've put a piece of tape where it's approximately a straight line. Yeah, I hope you can see that line there. Okay. Oh, look, here's another one. Okay, if I stretch this out, I get approximately a straight line. But wait, when I put it back down, you can see that those 2 lines don't stay the same distance apart. They're curving away from each other in our Euclidean perspective, and they're not going to meet, which is how we're going to define parallel. We're going to define parallel not by them staying equally distant, but we're going to define them by not crossing, staying in the plane, the approximate hyperbolic plane, but never meeting. Okay, so here we have parallel lines that don't cross and yet diverge. You can see here was one of my lines. Here is another one of my lines. Here is another one of my lines. But when you put it flat, you can see that this line and this line, although they're parallel by our definition, are diverging from each other. Well, that's interesting. But now we'll call this our original line, and we'll call this line parallel to it, and we'll call this line parallel to it, because they're never going to meet. They're never going to meet this line, but they do cross. Here is a point, not on this line, and here are 2 lines that intersect at that point, and yet will never intersect with this line. They'll just get farther and farther away. That's interesting. Here's a triangle. Here's a line. Here's a line. Here's a line. But if you hold up the triangle, you can see that it's pinched. Okay? So because these lines, when you stretch it out, actually look kind of curvy relative to each other, that pinches this triangle. And this triangle only adds up to approximately 130 degrees. And if you put 2 of those 130 degrees triangles together, you're going to get a quadrilateral, but it will not be 360 degrees. So there's the Hyperquilt. Thank you so much. And my favorite thing about the Hyperquilt is it's very, very cuddly. Thank you so much.